Hello to Darkness344 here, and in today's video I'll be doing a quick showcase of this IO, I guess, that I've designed, and I'll probably also do a tutorial because it isn't exactly that big. So there may be a timestamp on screen if you want to skip to the tutorial part. But for now, I'm just going to show off what it can do and how you can use it. So the first thing to note is that we have separate in and out ports. This is because on, say, like a regular computer, like we use in real life, you might have a thing called a tri-state buffer, which, as it's in the name, it has 3 states. So it can either work as a, let's actually just put them on sides. It can either work as an input, as an output, or as just high impedance, which also pretty much just means disconnected, so disconnected. What this means is that if we have a tri-state buffer, we can basically select between whichever one we want. So say we want the IO port to be an input, well, we can select it to be an input. If we want it to be an output, we can do that. Or if we want it just to not be connected at all, so not used, then we can disconnect it like that. And the reason you'd have to disconnect it when you're not using it is because in real life you have like voltages and signals and stuff, and it can just break things or damage components, so it's better to disconnect it if you're not using it. So now, why do we not need one of these in Minecraft? Well, because Minecraft is all just digital logic, so you have ones and zeros, and yes, you do have comparators, but because we're transferring all the logic mainly in binary instead of hexadecimal, it's not going to matter too much if the signals kind of like mix. So for instance, say we have this line over here, and we have some different inputs to the line, like this, with repeaters. Well, if I power this one, it's not going to like power this redstone over here, because of the repeaters only letting signal go one way. Where in real life you might have a few issues with this, or at least if you power 2 of them at the same time, the voltages can cancel out, and this could not turn on properly, and you just have a few problems like that. Where in Minecraft it's all digital, so we can avoid all of that. So instead of even having the tri-state buffer at all, we don't need any buffer, because we can just use a separate in and out port. Instead of having a tri-state buffer, you could just have a dual state buffer, I guess you call it, or just a regular multiplexer with 2 different inputs. And the way we'd normally do this is let me see how to build it. So if we have comparators like this can be one of them, this can be another, and then we can switch whichever comparator on or off. So we might have to use redstone like this to do it, but you get the idea. So if we'd be able to select between which one. So yeah, and it'd all just work on one lamp. The problem about that is in Minecraft we also have signal strength, which means if you have repeaters like this, the signal's still only going to be able to travel one way. So if you're using a port and use it for multiple devices, you don't want to have to break all your cable or your redstone, place it back down, and swap the repeaters to be the other way around, because that's just really annoying and painful. So instead what we do is we have just an in port and an out port, and whichever one you want to use. So say you want to use port 0 for instance, and you want it to be an input port, or just connect whatever line or device you're inputting to your computer even instead, up to the input port, just like this, and it should just work. You don't actually need these lamps here, I just put them there so it's a bit more visual. We can just break them and hook it right up to this comparator over here. And the same goes for output. So over here we have the output, you don't actually need that either, but we'll just keep it there for now. But the output, all you have to do is connect it up, just like that. So it's a very simple way of getting an out or an in. So I've got this little setup over here where I've just placed levers on the input side of just port 0, and that will just make things a bit more easy. Just note that I haven't actually hooked up any control logic down here. We'll just be doing it manually, so there'll be no like address selection, because I'll just do it manually, select like the correct one. But yeah, so for instance, say we just want to say we put a number on the in of port 0, because it's going to be an input device for now. So let's just do 11001100, and then over here will be our actual data bus, and when we want to read port 0, we can just do that by clicking this lever over here, and we will get out that number over there. And say we wanted to read a different port, well, we'd select the port we want to read, for instance port 1 over here, and we can read from that. So as you can see, we can read the different inputs from the different ports. So the same goes for outputting though, but instead of working like this, of course we have to actually give it data from the data bus. So for instance, if we go 0 0 1 1 1 1, and this is just normal because this is part of the data bus. But so we put this number in, so 0 0 1 1 1 1 0 0, and we're going to put it in the same port, so port 0. I think it's this lever over here. We're just going to go like this. The power of magic editing turned the comparators into repeaters because I placed down comparators, whereas meant to be repeaters. But as you can see, we can read it out like this. So this also does mean that the way I've designed this, say we decide to change what's on the data bus, the port will still keep outputting whatever's on until we set it to something else. So say we want the port 0 to stop outputting this number, we're actually going to have to input 0 from the data bus and update the registers inside the port, and it'll set it all to 0. So it's kind of useful because you don't want to have to you don't want your device to only be reading an input when the data bus is outputting an input, because in your computer you're not always going to be outputting something through the ports. So for instance, say we want a number like this, we'll just output it to port, or just update the port register. So now it doesn't matter what's on our data bus, because say we could do something else with the computer, we could be like adding numbers instead, so we'll have different numbers on it. It doesn't matter what numbers on it, because it will stay, it'll just stay whatever state it is. And so as you can see, we have zeros. Actually we have some of these, but if we just turn them all off, we have a bunch of zeros, and as you can see, it's still giving us an output. So we can also turn this off and it shouldn't change. So now that I've showed off kind of most of this, of course you can read and keep the data being output at the same time technically, because say we read in 2, that's not 2, that's actually 64, but we can read it in, as you can see it's being read in over here, and technically this also means you can write, well, input from one port and output to another port like immediately, and that means you don't actually need your CPU to be doing any of that. So say if you had like because this is special IO, if you don't memory map it, then it'll become special IO, and if you have a separate controller like an IO controller or something, you could actually have the data bus on it separate to your computer data bus, but allow your computer data bus to input and output from it. This means that you can communicate between devices without wasting computer cycles, so freeing up a bit of resource. So for instance, let's go from this one. So if we just put the number 10100000 into the input port of a 1, I guess, and we're going to read from it onto the data bus, and then we're going to write to port 2. I'm pretty sure this is port 2, yeah. So if we write by doing this over here, this lever, I think that's the wrong one. Oh yeah, because I have to replace the comparators now. So now that they're replaced, as you can see, we'll just activate it. So I think it was this one, but we'll just do it on this last one over here because, well, port 2. So it'll just be easier. So as you can see, we've inputted it from this one and we can output it from this one, and even if this changes now, it doesn't matter because it's been saved in this one. So it's a fairly smart system, and technically you could kind of use this. You might have to do a few modifications for some sort of network switch. There isn't really too much reason to use a network switch in Minecraft, but if you have a lot of devices and you're not really using serial, or well, I guess you could still use serial with this, but if you have a lot of devices, then this could kind of be useful for doing network switching and stuff. But yeah, so on to the tutorial now. So the first thing you're going to want to do is find an empty space like this. You can use the set block command if you just want to place a block like this, but we're going to be building the inputs and outputs first of all. So we're going to place a comparator down, set it to subtract mode so we can input from the side like this. so we can cancel any signal that goes through, for instance like this. Seeing as we have this signal going through right now, if we power this, it will no longer be allowed through because it's just doing some subtraction. But this will be our input, so we're just going to place a redstone lamp like this and our lever, and this will be our output over here, so we're just going to block up like this and then place a repeater down like that. So now that we have this main piece of circuit down, we're actually going to break this. This was only for testing. We're going to place a block here with another repeater. Then we're going to place a block here and another comparator on subtract mode. So as you can see, this design is 4 wide and it should stack fairly nicely. Then what we're going to do is we're going to get a barrel, for instance like this one. We're going to place it down here, and then we're going to make sure to fill the barrel with items. So for instance, I don't have any items in, but what we do, you're going to want to fill the barrel all the way up so it gives out a signal strength of 15, so a full signal strength. And I have some pre-made ones already here, which I've used, which I've created using just filling a barrel, then holding control middle mouse button, which will save the MBT data, and we have this over here. So this will output a full signal strength. And the reason we put this down here is for when we stack the design horizontally, this comparator will read from this barrel over here. So for instance, let's actually just bring an empty one for now so we don't get any mess if I break it. As you can see, this barrel, when we stack it over, it'll be over here. So this comparator is reading from it. So for instance, if the comparator was this side, it would be, oops, like this. So now once we've done this, we're actually going to want to somehow power this comparator, and so we can toggle it on and off. Then we'll subtract numbers from it or not, so we can toggle this input on or off. And we're going to want to place a block, piece of redstone dust, block here, break this one, and then you can place a redstone torch like this. And this means by default it'll provide a 15 signal strength into the side of comparator. So say if we try get an output like this, if we power this on, it's going to give us nothing because it's being subtracted from that. Well, I mean, this is being subtracted from that. So say even if this was signal strength 15, which it is at the moment, 15 minus 15 is 0. So we get a signal strength of 0 out. Then of course if we turn this off, it'll be 15 minus 0, so signal strength of 15 out. Now we've done this part, we can work on the actual rest of it. So what we're going to do is we're just going to go block like this, and we'll do the same on both sides. And because this one is the input, we're going to go another block and place a repeater, and this one is the output, so another block and a repeater. So now that we have this, we're going to want to actually make a slab tower or glass tower, so we can actually, when we stack it vertically, we can power all these torches on or off. And the way we're going to do this is just get some glass or slabs. I like using glass personally, because on Bedrock Edition, redstone can travel both up and down. And we're just going to go like this. So as you can see, if we power it from the bottom for Java users, the signal will travel up and it will turn the redstone torch off, allowing signal to go through because the subtractor does not, well, subtract 0 from whatever's here. So for instance, if we put in a 1, we'll get out a 1 here. And if we turn this off, we'll get out a 0. So now we've done this, all we need to do now is the bus, and we can do this just by going along like this. And you're actually gonna have to place a block here, or else this redstone will be able to travel up onto the line. So if we had a block here, as you can see, it's doing that. So just fix this by using a block like this, and then these redstone over here will still be able to get powered through the block, and also be able to send power through the block to the repeater. Now we're just going to go around like this, and this is pretty much the whole design done. So now on to stacking. This is the bit where it's advisable to use something like World Edit, but you can technically just do this all by hand. I will be releasing a video soon going over different ways for World Edit or commands or even structure blocks, and that video will just detail how to actually stack these if you don't want to use the World Edit add-on. But what we're going to do is just if you're doing it by hand, it's very simple. You just have to build everything on top of it just by one block up. So as you can see, just like this, it's very simple. But if you have the World Edit add-on installed like me, make sure it's up to date and make sure it's working. And we're going to select this corner down here, try get the lever in, and we're going to select, we're going to place a block here, place a redstone dust, and we're going to select that as the other corner. And that's because when we stack it along like this, the bus will have to join to each other. So now we've got this, we're going to want to be able to stack it vertically. But we have this issue with this bit not fitting in, so we're going to go down like this, place block, break this one, just place a dust here. So in the selection, the dust is in, but the block is not, and that means this doesn't really matter at all. Now we've got this, I'm just going to stack it 8. That's really the maximum without using redstone torches to extend this. But we're just going to type semicolon stack 7. And that'll stack it down 7 times, which means we have 8 lamps in total, or 8 modules in total. Now that we have this, we can stack it horizontally. And first of all, I'm just going to break this and this. We don't actually need them. And to do this, we're going to select this redstone dust here. And we're going to go all the way down to the bottom and select, actually we want the levers in, don't we? We're going to select this block over here. So now that we have the selection, just make sure everything's actually in it. And then we're just gonna, we'll stack it this way. We're just gonna write a semicolon stack, and we're gonna stack it 3 times, so we get 4 modules. So now that we've stacked it 4 times, so we have 1, 2, 3, 4, we're going to want to, on the final one, where there's comparators going into this repeater, we're actually going to have to place barrels with the items in, or else it won't be activated. You also could, of course, just place redstone blocks like this, which is what I'm going to do, because it means if I accidentally break a barrel, it's not going to go everywhere, because I don't know if I have tile drops on or off on this world. So now that we've got this comparator down, the final thing that we're actually going to want to do is be able to toggle this comparator on or off, and we can do that by placing a block here, a redstone repeater, and then if we get out the glass again, build a tower like this. So we're going to select all of this, like this, so this one and this one, no, we'll just go the one below, like that. We're going to block down like this, redstone dust, so that's in the selection, and we're going to stack it 7 down, so semicolon stack 7, and that will fill in all of these. Now because we don't actually have it on the other ones, we want to fill that in, so we're going to select the whole module, so from here to we're going to go here, I guess. So we're going to go all the way down to bottom, select this one, and we'll just break this, we don't need it. So as you can see, I've selected 4 wide exactly, because that's how long the modules are, but I haven't selected these blocks. And we're just going to write stack 3. And there we go. We now have the glass on each of them. I really should have done that originally, but I kind of forgot. So that's pretty much the whole thing done. So the only last thing you're going to want to do is be able to build some control logic, and that's as simple as just going down to bottom. You're going to want to go like this, place a redstone torch, break this one, place a block, and place a redstone on the top of that. So it means you can more easily power this, like this, with a repeater for instance, without having to get a bit messy and use like repeaters and everything, because the signal strength will run out by the time it gets up here. So over here what I've done, I've just placed a bunch of blocks on top of the redstone with levers, and this means, well, it'll only work on Bedrock Edition. If you want Java, you'll have to place these at the bottom like I showed off earlier, but it means we can power them like this, so it's a bit more manual, so it's easier to use. Now what we're going to want is to actually add the repeaters onto the data bus, and if you want to get rid of the selection, you can just type in semicolon deselect like that, and it'll just disappear. But for the repeaters, since we're inputting over here, we're just going to have a repeater like that, and if we power this, we can see the signal strength only makes it up to here, and while it should be powering this one. So, well, we could either use a repeater like that, but this also means that these cells are no longer going to be synchronized. So for all of these cells to make it in sync with this one, you're going to have to add repeaters like this. But because this signal almost reaches, what we're going to do is, instead of doing this, we're just going to break this one and place a block like that. So that extends the signal just 1 over, but it means you need to input with a repeater. But as you can see, it reaches all the modules just fine. The only problem with this is that the first module over here, if you read from it, so if we put in a 1 and we read, and let's just turn the input off, as you can see it won't go through fully, but you can just always fix this just by placing the repeater here instead. So now we've done this, of course we can just stack it, but first of all I'm just going to break the ones off the end because we don't need these. And for our outputs of the data bus, you can just take it from the exact same spot like this and just have repeaters off like this, because the signal can travel both directions if because there's enough signal strength. If you have any cells more than 4, you're actually going to need to and you have repeaters in like this, what you're going to need to do is, instead of taking the output from this block over here, you're going to need to take it from this block over here, so all the cells can go into the output. And what you're going to have to do, unfortunately, is just run it all the way back like this with a couple repeaters, which will add to latency, but that's just the trade-off if you have a bigger system. So we're just going to stack this by selecting this corner and that corner. So we'll just get out this corner and this corner, and we're just going to semicolon stack 7, and as you can see, all the repeaters get stacked nicely, and these are our inputs over here. So now let's actually get to testing it. So say I input the number 11001100 into port 0. We're just going to read it like this, and we get that out here, but I actually forgot to place these back. And of course we get that out here, so 11001100. Just note that you can't have multiple, you shouldn't use multiple ports reading at the same time, or else of course the data will get corrupted. So when you make the control logic with the address selector or whatever, make sure that only one can be selected at a time. So that's the writing test, the input test. Now we're actually going to want to test the output. So what we can do is, for instance, we'll just put a number into port 0. So if we go say 11010001, for instance, and we just put that into port 0 with this lever over here, as you can see, we get that as the output. And no matter if we turn this off, for instance, let's just turn them all off, or you could swap it to something else, we'll still be getting whatever is stored in the port currently as an output. So yeah, I hope this video was useful. This is pretty much only used in more complex computers when you do proper I/O and stuff. But it's a fairly useful thing to have, especially if you want displays or keyboard inputs or any sort of input really. It's just a useful thing to have on your computer. And there are several ways of accessing it with your computer, like special access, or you can use memory mapping, where it will take part of your RAM address and it'll work. However, that's up to you, and that's really for another video where I discuss which ones you'd preferably want to use. So yeah, I hope you like this video. Please like and subscribe, and I'm out.